Bismillahirrahmanirrahim. We'll start chapter 9, which is about sequences and series. We'll start with the sequences. What do you mean by a sequence or infinite sequence? Is a function, but domain of that function is set of positive integers or non-negative integers. That's what we call sequence. So you have a sequence, A1, A2, A3, sequence of numbers. Usually write it also this way, or this way to say it's coming from from 1 to infinity. Assume that n starts at 1, sometimes starts at 0. Yeah. Now, if you look at this sequence, what are the terms in this sequence? So if a equal 1, if n equal 1, what will happen? N equal 1. What will be a1? It will be 3 minus 1 to the power 1. And that will be 2. If n equal 2, it will be a2. It will be 3 minus 1 square. That will be 4. N equal 3. What will be a3? It will be 3 minus 1 to the power 3, which is minus 1. That will be 2. N equal 4. What will be a4? It will be 3 minus 1 to the power 4, and that is 4. So very clear, this sequence will be what? Will be 2. 4, assume I'm starting from 1. Because if we start with 0, it will start with 4. Okay. 2, 4, 2, 4, and so on. So this will be the sequence. Look at this one. N equal 1. What will be a1? It will be 1 over 1 minus 2. That will be minus 1. N equal 2. What will be a2? Will be 2 over 1 minus 4. That will be minus 3 over 2. N equal 3. What will be a3? That will be 3 over 1 minus 6 minus 3 over 5. N equal 4. What will be a4? It will be 4 over 1 minus 8 minus 4 over 7, and so on. So my sequence Bn will be what? From n equal 1 to infinity. That will be minus 1, minus 3 over 2, minus 3 over 5. Is it? No, this is minus 2. What is this? This is minus 2 over 3. Yeah. This is minus 2 over 3. Minus 2 over 3. How it comes? Yeah, because of the denominator. Okay. Minus 2 over 3. So it's minus 3 over 5. Next one, minus 4 over 7. And so on. This one, n equal 1. What will be a1? A1 will be 1 over 2 minus 1, which is 1. N equal 2. What will be a2? A2 will be 4 over 4 minus 1. That will be 4 over 3. N equal 3. It will be a3. It will be 9. 2 to the power 3, 8 minus 1. That will be 9 over 7. N equal 4. What will be a4? That will be what? 16 over 2 to the power 4. 2 to the power 4 is what? 16 minus 1. That will be 15. That will be 16 over 15. That's 16 minus 1. 2 to the power 4 is 16 minus 1. Okay. So this sequence will be what? 1, 4 over 3, 9 over 7. Oops. and 16 over 15. And so on. Yeah. Or sometimes they will be written in a recursive way, a recursive definition. I have D1 equal 25, D2. Now when n equal 1, when n equal 1, what I have D2 will be equal D1 minus 5. What do you mean by recursive? It depends on the one before. So I have 25 minus 5, and that is 20. Now n equal 2, so I have D3 is D2 minus 5, and that is what? 20 minus 5, which is 15. N equal 3, I'm getting D4. Because I have 3 plus 1, that is 4. It will be D3 minus 5. And that will be what? That will be, yeah, D is 15 minus 5. That will be 10. N equal 4. D5 is D4 minus 5. That is 10 minus 5, which is 5. So this sequence, the n, I'm saying n equal 1 to infinity. N equal 1 to infinity. You can start from 0. It's up to you. No, this one you need to start from, because you have D1. I need D2. For sure, I start from 1. Yeah, that will be 25, 20, 15, 10, 5. I'm sure I know the rest. 0 minus 5 minus 10 and so on. Okay, usually we describe the sequence in 3 ways. Either preceding rotation, this one, or by using the defining formula, the formula itself. Like in this case, n over n plus 1. That will be my formula. And third, by writing out the terms. What are the terms here? I have, if n equal 1, I have half. N equal 2, that will be 2 over 3. N equal 3, that will be 3 over 4. N equal 4, 4 over 5, and so on. This one, the same thing. This is the formula. Now, what are the terms? N equal 1, be careful. I have minus 2 over 3. N equal 2, I have plus, but I have 3 over 9. 3 over 3 square, and that's 3 over 9, which is 1 over 3. So write it 1 over 3. N equal 3, you have negative. You have 4 over 3 to the power 3, which is 4 over 27. N equal 4, I have what? This is minus. This I have 5 over 81. 3 to the power 4, and so on. Same thing here. I have square root n minus 3. Be careful, I'm starting from where? I'm starting from 3. Starting from 3. So what are the terms? 0. Then I have 4 minus 3, square root of 1, which is 1. 5, that's square root of 2, square root of 3, and so on. This one, that will be cosine n pi over 6. Now I'm starting from 0 in this way. This is starting from 1. Starting from 0, n equals 0, that will be 1. N equal 1, that give me what? Pi over 6. Cosine pi over 6 is what? Square root 3 over 2. N equal 2, I have pi over 3, that will be half. N equal 3, that's give me pi over 2, that will be 0, and so on. Yeah, this one, 1 over 2 to the power n. What are the terms? N equal 1, I have half. N equal 2, 1 over 4. 1/8, 1/16, and so on. Yeah, usually 3 dots. Yeah. This sequence, we can denote it as I said, we can write it an equal this, and we write here an. Yeah, instead of doing it this way, yeah, it's the same. An. Yeah, this is the defining formula they mean, n/n+1. Yeah. So we say an equal this. Yeah, you can write it this way or that way, it's up to you. But this is the defining formula. Or we can write it to n, as I said. Yeah. This is which is 2, 4, 6, 8, 10. How to write it? It's very clear. It's 2 times 1, 2 times 2, 2 times 3, and so on. So it's 2n. If I have 1, 3, 5, 7, 9, these are the odd numbers. These are the even numbers. This is the way to write it. N equal to n. This one, it's what? It's 2, 1 is 2 times 1 minus 1. 3 is 2 times 2 minus 1. 5 is 2 times 3 minus 1. So I can write it 2n minus 1. So I write an 2n minus 1. This is if I'm starting from where? If I start from 1. Because at 1 it will be 1. There's one way. Another way I can write it 2n plus 1. But I will start from 0. N equals 0, it give me 1. Okay. Yeah, this is another way to write it. Okay. Yeah, this sequence minus 1, 1, minus 1, 1. So very clear, I can write it as what? Minus 1 to the power n. Yeah. Or, yeah, you can write it minus 1 to the power n plus 1. It depends. You want it from where to where? From, let me just be sure. Here, I'm starting from, I want my starting 1 to be minus, so I'm starting from 1. If I want it to be n plus 1, I should start from 0. Or if I want it to be 1 minus 1, I write it minus 1 to the power n plus 1, and I start from 1. Yeah. What I meant in this one is the same as this one, where n is equal 0 to infinity. These are the same. Now, if I want it to be 1 minus 1, I will write it either minus 1 to the power n starting from 0. Means my first one will be 1. Or I can write it minus 1 to the power n plus 1 starting from 1. Yeah, both are correct. This sequence, I think we did it before. Yeah. It depends. He's starting from 0 here. But in the previous one, I was starting from 1. With that, I'm having minus 2/3. Yeah, I'm having this. But why he have 1 and 1? Because he start from 0. So at 0, I have what? 1/3 to the power 0, which is 1. Also, there are sequences which is impossible to find an explicit formula for them. If we say what is the sequence Pn, where is Pn is the population of the world in January 1st, in the year N. So in the first year, I have, what is the population? Second year, this is, you cannot find an explicit formula. You cannot see a pattern in it. Okay. Also, if we say the digit in the n decimal place of the number E. I know E is 2.71828182845. You cannot find the decimal, the digit. I can say no, A1 will be 7, A2 will be 1, A3 will be 8, but I cannot find the formula for that. Okay, I write A1, 7, A2, 1, A3, 8, but I cannot find like a formula. Also, there is something called Fibonacci sequence, which is F1 equal 1, F2 equal 1, Fn will be Fn minus 1 plus Fn minus 2. It's like a recursive definition. But now I need a dependent 2, yani F3 will be F2 plus F1, and that will be 1 plus 1, which is 2. So this is 2. F4 will be F3 plus F2. That will be 2 plus 1, which is 3. That will be 3. F5 will be F4 plus F3. That will be what? 3 plus 2, which is 5. But you cannot find the formula for it. You can't have an explicit formula for it. So sometimes it's not easy to find an explicit formula for that. Sometimes the question is to find the formula. Sometimes it just will list the values, which is easy. But sometimes the other way. I need to find the formula. How to find the formula for such problem. Yeah. One of the things, assume that we have a pattern, huh? Yeah. One of the things to think about it is to split the numerator and the denominator. Sometimes no need, sometimes yes. We need to think about this. So I have in the numerator, I have what? 3 minus 4, 5 minus 6, 7, and so on. So it's clear for me that's 3, 4, 5, 6, 7. Yeah. So how to write this? And there is a minus sign. There is plus, minus, plus, minus, plus. So I have what? This is if I want to write it. It will be minus 1 to the power something. This is how to write it. Usually I start at n equal 1. So at n equal 1, I have 3. At n equal 2, I have 4. Forget about the minus. Then it means n equal 1, I have 3. N equal 2, I have 4. N equal 3, I have 5. I will come back to the minus sign. That give me what? That give me n plus 2. Yeah, very clear. I have n plus 2, give me this. N plus 2, give me this. Now it comes to the minus. The first one at n equal 1, it's plus. So I have n plus 1 or n minus 1. It's up to you. So the negative will come in the even ones. Odd places I have plus, and even places I have minus. So the odd 1 plus 1, that 2 will give me even. The even give me plus. I mean, with the odd I have a negative value. That will be the numerator. Now when it comes to the denominator, I have what? 5, 25, which is 5 square. 125, which is 5 cube. Yeah, now it's very clear that I have what in the denominator? I have 5 to the power n, starting with n equal 1. Huh? It's 5 to the power 1. So what will be the formula? It will be minus 1 to the power n plus 1, or n minus 1. He wrote it n minus 1 times n plus 2. That's the numerator. The denominator is what? 5 to the power n. Okay. Finding the n term of a sequence, or the formula as an expression for the n term. This is they call it the n term. This is they call it the n term. Because the term, it comes at the nth place, starting from 1. Okay. So here, if you think about it, it's what? Yeah, it's 1. Then this is minus 1 over 2 square. So I can think of this 1 square. 1 over 3 square minus 1 over 4 square, and so on. So very clear for me. That will be what? Starting from n equal 1. So I have the even, starting from n equal 1. I have the the odd places. I have plus. So it will be minus 1 to the power n plus 1 over n square. That will be my an. So I have a1, you can check, will be what? 1 over 1, that is 1. a2 will be negative 1 over 4 over 2 square, which is 4, and so on. I think it's easy to figure out. This one, 2, 8, 14, 20. Yeah. How to think about it? This is 2. Yeah, what's the difference? I have this is 2 plus 6. This is 8 plus 6. This is 14 plus 6. So I think this should be a recursive way. So I have the a2, I can write it as a1 plus 6. And this one, a3, I can write it a2 plus 6. So that means I can write it an will be an minus 1 plus 6. Yeah, in a recursive way. Or I can write it also, this is one way. I can write it as, is what? This is 2, which is, yeah, starting where you need to specify the starting point. For a1 equal 2, then a2 will be 8, a3 equal 14, and so on. This is one way. And this is, you can write it this way. There is another way to write it. Is there another way to write it? Yeah. It is 2 times 1. Second one. The 8 is what? No, I think, yeah, I think this is the best way to do it. In a recursive way. Yeah, so a2 will be a will n equal to a1 plus 6, that will be 8, and so on. So this is correct. So this is the way to write it in a recursive way. Converge or diverge, we did not discuss it, so I will leave it later. Now, when we discuss the sequence, also we need to discuss the sequence will converge or will diverge. And for example, all of these sequences which we discuss, I'm reaching now as n goes to infinity, what will happen? I'm reaching a value or I'm reaching nothing. Okay, so we'll say the limit of the sequence goes to L, the same limit which we discussed in Math 101. Huh? Also, we can do it this way. We can think of an as function of n. So the things which comes with this deal, the way we deal with the function, we know it, limit of x goes to infinity. If that is L, then I have the limit of an, the sequence, it will be the same L as n goes to infinity. So I can think of this sequence formula as a function of positive integers for every positive integer n. Yeah, and then I find the limit. And for instance, this one, I know that the limit x goes to infinity of 1x to the power r, if r is positive, this will be 0. That will tell me, since I have f of n will be, now f of x is 1 over x to the power r, so f of n will be 1 over n to the power r, which is an. So that means the limit of an as n goes to infinity, which is the limit 1 over n to the power r as n goes to infinity, where r is positive. All the cases r is positive, this will be equal to 0. So the same thing as the limit of the function. The properties which is we know about the limit, it will works. The limit of the sum is equal to the sum of the limit, difference, constant times, everything is the same. Powers. Also, we have the squeeze theorem. If I can squeeze, remember, if I can squeeze the function between two functions where the limit of these two functions goes to the same value, the same thing with the sequence. If I can squeeze the sequence between two sequences. Okay. If the limit of absolute value going to 0, then the limit of the original sequence goes to 0. These are some of the properties. When the sequence fails to have a limit, usually think of it if the terms increase without bound, if the limit goes to infinity, or decrease without bound goes to minus infinity, or when it is alternate. For example, this one, I know it's 2, 4, 2, 4. We did it before. 2, 4, 2, 4. The problem is I don't know where I will stop. So we say the sequence diverges. So usually we need to deal with the sequence diverges or converges. These are the most important thing about the sequence. So what we did until now about the sequence, we did how to write, how to think about the way they write the sequence. We say we have three ways, either in this way or as a formula or as terms. And also we discuss some problems, how to write the terms in right of the formula. In terms of a formula, yeah. If you have numbers, how to write it in as formula. Now we'll go to the limit. The things which we did in Math 101 about the limit, we'll do here. So what is the limit of this? Very clear, this is equal to 0. So we say the sequence an equal 1 over n. This sequence converges to 0. Since this limit is equal to 0. And this is what we did here. We say the sequence, yeah, you say the limit, the sequence will converge. If you can make the terms, we say the sequence converges or convergent if it have these things. Okay. Yeah. This one, how to find the limit, is the same degree. You can deal with it this way. You can say f of x equal x over x plus 1. Yeah, actually, also I need to do this here. I have f of x is 1 over x. So it will be the limit x goes to infinity of f of x. And we limit x goes to infinity of 1 over x, and that is 0. So it means the limit of f of n as n goes to infinity, which is limit n goes to infinity of an, which is limit n goes to infinity of 1 over n. That will be the same thing. Yeah, the same thing here. I have f of x plus 1, x over x plus 1. So what is the limit as x goes to infinity of f of x? That will be the limit x goes to infinity, x over x plus 1. I have same degree. I have the leading coefficient. I have 1. So that means an, which is f of n, which is n over n plus 1, we have what? We have the limit an as n goes to infinity will be equal the limit as n goes to infinity of n over n plus 1 will be the limit n goes to infinity f of n, and that will be equal to the same L. So this is L, that will be L, which is 1. So this limit is equal to 1. Don't need to do all of this, but just to explain it. This one converge or diverge. Yeah, so we say converge. Huh? If it is equal to a value, then it means converges. So we say this sequence an converges to 1. Huh? If it is going to infinity or minus infinity or alternate, then we say it diverges. This one, converge or diverge. Yeah. Think about f of x as x over square root 10 plus x. How to find the limit? Limit f of x as it goes to infinity of this function. That gives me limit x goes to infinity, x over square root 10 plus x. Very clear. The degree of the numerator is more than the degree of the denominator. Or I can do this trick. I divide by x here and there. Or you know what, I can divide by this one. I divide by square root of x. So I have limit x goes to infinity of what? X is positive, so I can take it inside. I have x over half. I have x over square root of x. This will be square root of x. This one will be square root 10 over x plus 1. Now apply x goes to infinity. That will be infinity. This one will be what? 0 plus 1. So I'm getting infinity. So this sequence converges, convergence sequence. We say either convergence sequence, or converges, diverges, I mean. It's not a convergence, divergence sequence. What is this? It's divergence sequence, or diverges, or diverges to infinity, or diverges. Okay. This one, how to do it? I need to find this limit. So think about f of x, limit f of x is what? Ln x over x. I want to find the limit of f of x as it goes to infinity. That will be limit x goes to infinity, ln x over x. How to do ln x over x? You need to remember all the ideas we dealt with the limits. So one idea is L'Hopital's rule. We need to deal with L'Hopital's rule in this case. So if I have infinity over infinity, I can do the derivative. So I limit x goes to infinity, derivative of ln x, which is 1 over x, derivative of x, which is 1. Now apply the limit, you get 0. So this sequence, so I have the limit is equal to 0, or you can say this sequence converges to 0. We can write an is f of n. So the limit of an will be equal to 0, equal to L. It's the same. This sequence, yeah, we know this sequence minus 1 to the power n. Actually, it's what? Assume starting with n equal 1. It's minus 1, 1, minus 1, 1. So it will alternate. So this sequence diverges. Because I will not know as I'm reaching infinity what will happen. It's minus 1 or it's 1. Because of that, it will we say the sequence diverges. I don't know a specific value that will reach either -1 or 1. This one, yeah, think about of x as -1 to the power x, x over x plus 1. I need to find the limit as x goes to infinity of -1 to the power infinity, -1 to the power x, x over x plus 1. If we need to find the limit of f of x. What will happen? I know that the limit as this goes to infinity of x over x plus 1, that will be 1. But I have a problem here. This is goes to 1, yes. This is goes to 1. But this one will alternate. So this sequence, so the sequence an diverges. I don't know, as n goes to infinity. This goes to 1, خلاص. But this one will alternate, so I don't know, it will go to what? To -1 or to +1. So it will diverges. This one, yeah, my f of x is what? -1 to the power x over x. So you have to do the limit as this goes to infinity, f of x. That will be limit x goes to infinity, -1 to the power x over x. I know that the limit of 1 over x as this goes to infinity, that will be 0. Yes, this is still alternate. However, so it's either -1 or -1 or 1, but still it will be multiplied by, it will be a value times 0, because the limit of 1 over x is 0. So that will be 0. Goes to -1, goes to 1, who cares? But the value at the end, it will be 0. So the limit of this sequence will be 0. So this sequence converges to 0. Because, yes, this value, I don't know what is it, but this will be 0 for sure. So in general, -1 to the power n times an enter, how to find the limit? It will be 0. Find the limit of this. If it is 0, then the result is 0, converges. If the limit is equal to a value goes to infinity or minus infinity, the limit of this enter without the -1 to the power n, then we say does not exist. The limit does not exist and it will be diverges. Yeah. So the limit does not exist. Here we say the limit does not exist. Does not exist. Yeah, same thing here. The limit does not exist. Yeah, just so that we have the same terminology. Okay. This one, find the limit of this sequence, whose n term is this. How to do that? Yeah, think about it. F of x is 1 plus 1 over x to the power x. I need to find the limit as x goes to infinity. That will be 0, 1 to the power infinity. And this undetermined form. If you remember, we work it out this way. We say y equal this. Then I take ln of both sides. Ln y will be x. Ln 1 plus 1 over x. So I take now the limit as x goes to infinity of ln y. That will be the limit as x goes to infinity of this. which is infinity times 0. So I need to write it in terms of function over function to make it ready of as L'Hopital's rule over 1 over x. Yeah, that will be limit x goes to infinity of what? L'Hopital's rule, I have, what is it? 0 over 0. So, do L'Hopital's rule, I have what? 1 over 1 plus 1 over x times, that will be 1 over 1 plus 1 over x plus 1 over x, yeah, times derivative of things 0 minus 1 over x square over minus 1 over x square. That give me what? This cancelled. As goes to infinity, that give me 1. So, yeah, let me make it in a better arrangement. Yeah, so I need to deal with the limit as it goes to infinity of this function f of x, which is the limit x goes to infinity 1 plus 1 over x to the power x. So what I will do, I will take y as 1 plus 1 over x to the power x. I have ln y will be x ln 1 plus 1 over x. Now I find the limit as it goes to infinity of ln y. That will be limit x goes to infinity of x ln 1 plus 1 over x. And that I can rewrite it limit x goes to infinity ln 1 plus 1 over x over 1 over x. Now this one is 0 over 0. So using L'Hopital's rule, I have what? 1 over 1 plus 1 over x minus 1 over x square over minus 1 over x square. This is cancelled. I'm getting 1. Am I done? No, because that means limit as it goes to infinity of ln y, that is 1, but I need the limit of y. So the limit, I didn't make this y. Limit of y as it goes to infinity will be e to the power 1, which is e. So the limit as n goes to infinity of an, which is the limit as n goes to infinity of 1 plus 1 over n to the power n, that will be e. So the answer is, so it converges to e. Converges to e. Yeah. This one, yeah, this one easy one. I have the limit of Pn as n goes to infinity. Yeah, I can think of f of x as x over 1 minus 2x. So what is the limit of f of x as it goes to infinity? That will be limit x goes to infinity x to 1 minus 2x, same degree, so that will be minus half. So the limit of Bn will be minus half. Okay. N square over 2 to the power n minus 1. But find this limit. So my f of x will be x square over 2 to the power x minus 1. Okay. So I need to find this limit. Limit x goes to infinity, x square over 2 to the power x minus 1. Okay. If you apply it as infinity over infinity, so I can apply L'Hopital's rule. I have what limit is goes to infinity 2x over, this is what, 2 to the power x ln 2. Apply it, I have still infinity over infinity. So this one equal limit x goes to infinity 2 over what? 2 to the power x ln 2 square, ln 2 times ln 2. Now, if I apply the infinity, I have 2 over infinity, which is 0. So this sequence, the limit of an when n goes to infinity will be the limit as n goes to infinity of n squared, and that should be equal to 0. So it converges to 0. An converges to 0. Yeah. Sine n over n. How to do this? But n goes to infinity. Think about f of x, or you can do it right away as a sequence. And instead of dealing with f of x, let me deal with it as a sequence. I know sine n as a squeeze theorem. We need squeeze theorem. So as I said, all the things which we did before, we can do it again. Sine n is between -1 and 1. So sine n over n is between -1 over n and 1 over n. So if you call this Bn and call this Cn, so what is the limit of Bn as n goes to infinity? Which is very clear. That will be 0. What is the limit as n goes to infinity of Cn? Which is very clear. That will be equal to 0. So this is goes to 0. This is goes to 0. So for sure this, by the squeeze theorem, goes to 0. So this limit is equal to 0. Sine pi over n. Sine pi over n. Now it's different a little bit. So I have the limit is equal to L. The limit of this is equal to a value, and the function is continuous. The same thing which we did with the functions. If the function is continuous, I can take the limit inside. This is what we'll do here. So this one will be sine of the limit as n goes to infinity of pi over n. So all the things which we did with the limit, we can do it now with for the functions. We can do it for the sequence. Most of the properties, if not all. Then I have sine. What is this? Pi over infinity. That will be 0. So that will be sine 0, which is 0. So this will be the limit. 2n pi, the same thing. I can take the limit inside. That will be tan limit n goes to infinity of 2n pi over 1 plus 8n. That will be tan. What is this? Same degree with n. So I have tan 2 pi over 8. That will be tan pi over 4, which is 1. R to the power n. There's something special about R to the power n. What is the limit? As n goes to infinity of R to the power n. It depends on R. If R is between -1 and 1, then it will converge. If R is between -1 and 1. Diverge otherwise. These are the only two cases. R equal 1 or R is between -1 and 1. It will converge, otherwise it will diverge. Okay. So if I have -half to the power n, so I have R to the power n. What is R? -half. I know R is between -1 and 1. So right away it will converge. It will converge to what? To 0. Yeah, by the way, the limit is equal to 0 if R is between -1 and 1, and it's equal to 1 if R equal 1. Because if it is equal to 1, it is 1, 1, 1, 1. So for sure the sequence will converge to 1. E to the power n, think about E. E is greater than 1. So I am in which case? Yeah, let me state it in a good way. I have let me state it. Limit R to the power n as n goes to infinity. I have what? Let me do it this way. 0 No, not 0. Diverges if R is less than -1, less than or equal to -1. Because with -1 it will alternate. 0 if R is between -1 and 1. 1 if R equal 1, and diverges if R greater than 1. I think this is good. Yeah, this is better. So I have E greater than 1. So what will happen to this sequence? It will diverges. Look at this. Yeah. Yeah, I think I'll stop here. Later we'll talk about the factorial, and we'll do things related to factorial. Yeah. Yeah, let me stop here. Factorial, then we'll do something related to factorial. And then we'll do more problems. So my main point in this video, dealing with the limit for the sequence, to check the sequence converge or diverge, I need to check with the limit. So dealing with the limit is the same way as we did in Math 101. You need to deal with all of these properties for the sequence, including the sequence theorem, all of these properties. L'Hopital's rule, you need to review L'Hopital's rule, all of these things. Yeah, let me stop the recording. Thank you.